So we have derived the formula for the refraction from curved surface. We'll just revisit once again and we'll start the application of it. So if we have two media which is separated by a curved surface, and the curved surface is part of some sphere. So what we mean by this? It's a spherical curved surface. We do not take any random curved surface. We only take the spherical curved surface. And one side we have a medium. Other side is let's say air, or you can also assume some medium there side also. So it may be concave also. I'm just taking convex, it's easy to draw. So this is the curved surface. Let's say the refractive index of this side is mu. This side, let's call it air. And the radius of curvature, because it's spherical surface, so it will have a radius of curvature r, and definitely it will have some center of curvature. So again, there are two types of object. One, you can say real, other is virtual. How to understand it's a virtual object? If the incident light itself is converging, right?
So what did you ask?
There are two types of object, real and virtual, right?
Yeah.
So if the incident ray is something like this, which you need to expand further, or extend, actually, not expand, extend further. So when the light ray is coming this way, then this is the virtual object. So when the object is virtual, okay, the question is, what will be the mu for the object? Should we take the mu of the medium, or should we take mu of the air? How we decide the mu?
Sir, of the medium.
Mu of the medium. In the derivation, how we do, like what we do generally in derivation? We write this Snell's law, right?
Yeah.
And to draw the Snell's law, first we draw the normal from center. So this will be your center, and this is your normal. Actually, it's very close to normal. Okay. I can shift this, but it will okay, change the diagram. Now this will be the angle of incidence, right? This will be the angle of incidence. When we say mu, the formula that we derive was mu2 by v minus mu1 by v u equals to. So mu1 is the medium from which the ray is coming or is incident, and mu2 is always the mu in which the ray is going to refract. So the whole idea is, no matter which kind of object we have, whether it's a real or virtual, the medium from which the ray is coming and the ray medium is going to be incident, that is called the first medium. And second, we only decide after refraction has taken place. So after the refraction has taken place, what is the answer? Now it's mu. So you will take air as the first medium always, if the ray is coming from that side. If I put the object on the right side, and if the ray is going towards left, then the first medium is where the ray is coming and hitting the interface. So here the ray is coming from left. So left side is your first medium and the right will be your second medium. Now when it comes to u and v, then u and v will have a sign. And every distance we measure from where? From this point P. So if I call P as the pole, then every distance we measure from the P. And because the object is on the right side, so the distance of the object from the P will be the U. And because it is in the sense of P to O, P to object is in the sense of incident ray, that will become positive in sign. That is the only thing we can say about it. Understood?
Yes, sir.
So U is clear, mu1 is clear, mu2 is clear.
Yeah.
We never comment about V because V is something that the entire equation will decide. Okay. Okay. So for a real object, what we can say?
So that the U is negative.
The U will be negative for sure. The U will be negative. That is the only difference. So for virtual object, we always take U as positive.
Positive.
So if we have the real object, then U will be this side. So everything we measure from P. So P to O will be this sense, right? This is the P to O sense. And therefore the U
Yeah.
will be negative.
It's opposite to the incident.
Incident, because the light is going to be from O. If you begin any light, it will go like this. correct?
Yes.
So the ray of incidence, or the incident ray, will be like this. So because the sense is opposite, the U will have negative sign. If you understand this much, it is more than sufficient. And here the mu1 is this air. So mu1 is 1 and mu2 is whatever it is. So mu2 will be less than mu. That's 1. And if I draw one more, I'll just change the shape this time. This is easy for me to draw. I can do it like this. Now, because the curvature I have changed, you can understand one thing that so if the object is this side, again,
No,
the
but here
only
also
difference
U is
is,
negative only.
pardon?
Here also U will be negative only.
Correct. U will negative. What about the R? Now R will be on this side, no?
R will
Left
be
side.
positive.
Pardon?
R will be positive.
R will be also negative, no? The center of the circle will be on the left, isn't it? The center of the circle is going to be left, no?
Sir, but we decide by the direction of incident. Rewrite.
Yes, incident light. So where is the center? Center is here. So let's say
Oh,
some
yeah,
center is here.
it's on the left.
So if you go from P to center, how you are moving? Opposite to the right, incident right?
Oh, it's negative.
Opposite.
This is your incident ray. So the center, if you try to go from P to center, because you are supposed to only go from P. So P to C is also negative, no? So this will have R, which will have negative sign when we substitute the value. If R is the value, then it is minus R in while substituting. So the center of curvature will change and it will change the sign. So you have to be careful about R and U sign, and mu and mu2 is anyway clear. There should not be any ambiguity here also. See, only these ideas are sufficient. If you know these ideas, you will never make a mistake actually. Okay. It is clear. So R will have the distance P to C, and O, the object will have distance P to O, and because both are opposite to the incident ray, so the answer will be negative. Is this clear? Okay. Now
Yes.
the question is, for real object, what is the virtual meaning? Sorry, what is the real image? For real object, if the image is real, for real object, if the image is real, so when a medium having the reflection, if the image is also real, what do we expect? That the image must be on the opposite side. Like if the ray is coming from left, the image must be on the right of the interface. In this case, the real image of a real object will be on the two sides of the curvature. If both happens to be on the same side, then if one is real, other must be virtual. Okay, so if the object is real and image is also negative, if u is negative and v also turns out to be negative, it means the image is virtual. If u is negative and v is positive, it is real. And if u is positive and v is also positive, it is what is that? What will happen? If u is positive, if u is positive and v is positive, so it's a virtual image and real object, real image, virtual object and real image. So how to understand like a real, virtual, real? So
Sir, I got confused fully.
yes, very good. No worries. If u is negative, so the object is on the left. Okay.
Yeah.
Which means object is real.
Yeah.
And v is positive, so image is real. Real. If u is negative and v is negative, real, virtual. Let's make some more. If u is positive and v is positive, virtual, real. Okay. So what is the condition for a real image? That the location, okay, you can see if u is negative and v is also negative, if the object and image are on the same side, which is this is the case, u is positive, so object is virtual, v is positive, but the image is, what is the image? It is a real image. Both are positive. Now imagine if u is positive and v is negative. Now what does it mean? Object is virtual and image is also virtual. So look at the virtual. For virtual image, what do you see? For virtual image, there are two scenarios. Object may be real and object may be virtual, but you will see that the surface will decide which kind of image is possible. All four cases will not be possible in each case. Okay. So a concave surface can do something, and similarly a convex surface can do something. So we'll see one by one, and we'll try to understand what kind of image is possible. I mean, this is confusing, I know, but once I'll give you the example, you will understand which one
Sir,
is
but
possible.
now the examples you gave,
Yeah.
those were for general case or what?
No. This is like possibilities.
Yeah.
And these are not the cases. Like we'll see the cases according to the surface, because one surface cannot form everything. So let's see what is possible and what is not possible. So for concave surface, you cannot create virtual. It is not possible that u is also positive and v is negative. Like v is on the other side. It's not possible. So let's see one more. So first of all, we'll start with the concave surface. So let's say object is real. Object is here. R is the radius of curvature. Tell me the sign of U and R. What is the sign of U?
So negative.
And
Negative.
R?
Negative.
R.
R positive.
Oh, sorry, sir. R is positive.
The center of curvature is on the right, right?
Yeah.
So first step is, if you're not able to recognize these two things, then probably you will not get the right answer. Okay, so now having this, yeah. So now what you can add here? U is negative and R is positive. Okay, so let's call the distance as D. That's better because the U is a symbol, right? So formula is what? Mu2 by V minus mu1 by U, mu2 minus mu1 by R. First of all, what we know or what we don't know. So we know U and R sign. We never try to put the sign of V because V is unknown to us. V is still a symbol. And the answer will tell us whether V is positive or negative. We will not decide. So mu2 by V is how much? It is mu1 by U. So let's substitute the value. Mu2 is, let's call mu. Mu2 is mu. V, I don't know. So I'll keep as a variable or symbol. Mu1 is how much? 1. And U is how much? What is the value of U? What is the distance of object from the P?
-2.
Minus mu2 minus 1 upon R is, let's say R is, we are now putting as a, this is the formula R. Now we are also putting R as a value. So when you put R as a value, we have to put a sign.
R only.
Server plus R.
Plus. So mu is anyway positive, so I will not replace mu. So this is the answer. So now for real image in this case, for real image, the V must be which side? On the right side? The V must be a positive number, isn't it? Do you realize this?
Yes.
Yes.
And
Sir.
if that is the case, and now see how to understand this. This is simple. Think this way. Any light which is going from the O other than the principal axis, I will always choose the two lighters. One along the principal axis. Why? Because that is convenient. Other away from the axis, like this. If the light can meet the axis, then only I can say it will form the real image, isn't it? So there are three possibilities. It can either go parallel to the principal axis after refraction. It can go above the axis. And it can go below the axis. Out of these three conditions, tell me which condition will form the real image.
So the third one.
The third one we call real, and we also call 2 because 2 is parallel. So we say they will meet at infinity.
Yeah.
So 2 and 3 we call the real image. One is called the virtual because it is not going to meet the axis, right? Anyway.
So we have to extend it back.
So we have to extend backwards. That's why the V becomes
Negative.
exactly. Now you're getting the point that if I really want to have the virtual image, the sign of V will be
So negative.
negative. Okay, to inform somewhere, okay, as per the diagram, it's not possible to show you, but you can understand it's going to meet somewhere here. So the V is going to be negative, which means virtual will have negative V and real will have positive V. Do you realize this? So if V is positive, can we say image is real? Yes or no? Is this part clear? That V positive means real image. Hello, hello.
Yes, sir.
So, so from equation 1, if V is positive, can we say on the RHS is also positive? So this implies mu minus 1 upon R minus 1 by D is positive, which implies mu minus 1 by R is more than 1 by D, which implies R upon mu minus 1 is less than D. Obviously, if the value of D is greater than R upon mu minus 1, what you get? What you get? You get a real image. So only when the object is kept beyond this distance, what we get? A real image. Is this clear?
Yes, sir.
And if the D is equal to R by upon mu minus 1, then what we get? The image at infinity. That's the idea, right? So if 1 by V is, if V is infinity, 1 by V will be 0. Okay, not getting this. So when the image will be formed at infinity, or when the light ray after reflection becomes parallel to principal axis? If incident ray, or I can say, if refracted ray becomes parallel to principal axis, then image will be real and will form at infinity. Is this clear?
Yes, sir.
And if this is the case, can we say that mu by V equals to 0 then? Because V is infinity, then 1 by V is 0. And this implies what? The D is exactly equals to. So D itself will give you all condition that if D is more than, then it is real. So we can say, combining these two, we can say for a real image of a real object by convex surface, how we say it is convex or concave surface? So we see from the object side. So from the object side, if you look at the interface, it looks convex or concave?
Convex.
Correct. So this is for a real image of a real object by convex surface. The mathematical condition which turns out to be how much? D more than equals to R upon. Is this clear? For virtual image of a real object or virtual image of a real object, what we can say? D is less than. Is this clear?
Yes, sir.
Okay. So what you learn from here, that for a real object, the image can be virtual also. Yes or no?
Yes.
And image can be real also.
Yeah.
So a concave surface can form what?
Sir, what?
A concave surface can form
Both.
real as well as virtual image of a real
Yeah.
object. Correct?
Real object. Yeah.
So real to real is possible. Real to virtual is possible. Object. Is this clear so far?
Yeah.
Now imagine, I'll keep this table to fulfill later on, but let's say, what if the U is positive? If U is positive, let's say the incident ray itself is converging. If the incident ray is like this, if this is your object, if this is your D, the R is anyway positive here, isn't it?
Yeah.
So mu2 by V minus mu1 by U, but U is D, correct?
Yeah.
And it's plus D. Mu2 minus 1 by plus R. It is clear? So mu2, mu by V is how much? 1 by D plus, because mu is more than 1, R is positive, D is positive, the entire term is positive, isn't it?
Yes, sir.
So whenever the image is formed in the direction of incident ray, it is always real image. Once again, whenever the image is formed in the direction of incident ray, it is always real. Because for virtual, we need to trace back, isn't it?
Yeah.
Now here we are not supposed to trace back because it will bend. After refraction, it will bend and will meet the principal axis for sure. So if I choose another ray like this, both will meet here, right? So which kind of image is this?
This is a real image.
It's the real image. So can we have the virtual image here?
No.
It is not at all possible. So what we need to realize that for concave surface, the virtual object can only create real image, but virtual to virtual is not possible. We had a discussion similar to this in mirror also, if you remember.
Yeah.
So what you realize? That if the object is either real or virtual, if it is real, then the image can be real or virtual, but if it is virtual, then the only real is formed. What we cannot form is a virtual to virtual. This is very, very important, and only you can remember through the ray diagram. Okay. I'll draw one general figure for this surface to just summary everything at once. So to summarize,
Sir, I'm confused between the convex and concave.
We'll come to that. Okay, convex and concave. See, let's say you're sitting on the incident ray. The light ray is coming from left. Right?
Yeah,
If a person is on the left, what you will see? Which kind of surface? Let's say if a person is sitting here, what is the surface looking right now?
convex.
That's it. Like incident ray is coming from left, na? So we see always from the direction of incident ray. Like you think this way, which surface is being hit by the incident ray?
Sir, but this gray shade you have done,
Hmm.
it is the material, like it is glass.
Yeah, let's say
So if that is on the left side,
that is on the right side.
but if it is on the left side
It doesn't matter.
and the rays coming from the left side, then
Yeah, it is still convex.
Okay.
Convex one. Yeah. Convex means, and the convex surface is always the name, but the converging and diverging property will depend on the relative medium, not on one. So it is not necessary that every convex is converging and every concave is diverging. We can reverse the process by changing the mu, the way you said. If you change the medium on the left and if you make the right as air, and if the object is on the left side, it is surface wise it is convex, but property wise it will become diverging. Are
Yes.
you getting my point? Like
Yeah.
the property will change.
Yeah.
But the way we are saying convex, we can keep on saying convex. Concave, convex is geometrical shape, geometrical nomenclature. It is not to do with the optical properties. Okay, what optically is happening is a different story. What geometrically is happening is the name. Name is a geometrical entity. Okay.
Yes, sir.
So imagine, okay, first of all, always draw a center. That's a thumb rule. We draw a center. So once you draw the center, the next step is draw the normal. And now we can play with the rays. So there are multiple ways in the ray can come. The ray can come horizontally, exactly like this. If the ray is horizontal, from where is the object? What we can see? Where is the object?
Object is on the left side.
Where? How far?
Infinity.
Infinity. So we can say the light ray is coming from infinity. The incident ray is coming from infinity, isn't it?
Yeah.
And so when we draw a parallel line, it means the light ray is coming from infinity. Okay.
Yeah.
The other situation which are possible are like light rays coming from here, below this line. The third is like it could be above this line, but it's still below the normal. Quite possible. You can draw like something like this.
Yeah.
And the last will be it is above the line itself. So there are four possibilities, right? We can check one by one. If the light ray is coming from here or wherever, what is the property? It will try to bend towards the normal. And this is the normal. Okay. So now this light ray, the numbering, let me do the 1, 2. I can take fifth also, the unit, the one which goes this way on itself. So if the light ray is coming along the fifth line, it means it will hit the surface at right angle. So no reflection will take place. It will come to C directly, isn't it?
Yeah.
It means the fifth will form the image only at C. I hope this is clear.
Yes.
So the fifth will come to C, will form the image at C. Let's talk about the 1. So 1 will bend towards the normal. Correct? 1 will bend towards the normal, isn't it?
Yeah. So 1, 2, 3 all.
Yeah, I mean all will form, I mean bend towards 1, 2, 3, 4, everyone. Now, when I say it will bend towards the normal, then there are multiple possibilities. It may bend, but not sufficient to go below the horizontal. So one can bend in three possible ways. It will still remain above the horizontal. It may become horizontal, or it may become below the horizontal. How many possibilities are there? So this is for 1, 1 dash, 1 dash, 1 dash. There are three possibilities for 1 itself. Do you realize this? Except this one. So even the 1 is coming from below, it means 1 is coming from somewhere on the axis. So 1 is representing which kind of object? A real object. Correct? 1 is representing a real object. Do you realize this?
Yeah.
Hello, hello,
So
hello.
the second line, the orange second line. The first one is yellow. The second one is orange.
Yeah, yeah.
That one can still go outside the
Outside the.
gray area if it extends.
Yeah, it can go, no? Why not? But the thing is, for 1, the object is here. This is for 1. Now what I'm saying is that after reflection, it can go this way. So the first 1 dash, let's say 1 dash, 1 double dash, 1 triple dash. Make it like this. So 1 dash is going to meet the principal axis, yes or no?
No. No.
It means it will not form the real image for sure.
Yeah.
So 1 is real, object is real, but image is virtual if it is not bending sufficiently.
Yeah.
If it will bend and become parallel to the principal axis, it will meet at infinity, you can say.
Yeah.
So it is real.
Yeah.
And if it really bends more, then it's a good thing. So it will again
will
form the real image. Understood?
Yeah.
Okay. For 2, I mean, there are many possibilities you can do. For 2, the 2 itself is horizontal, so it will bend only below, right?
Yeah. It will always
It will always form
real image.
real. It means if the object is at infinity, the image is bound to be real.
Yeah.
Why? Because the only condition that we need to remember is that D should be more than R by mu minus 1, right? For reality, for real image. Isn't it?
Yes.
I hope
Sir.
you remember we have discussed this before.
Yeah.
So infinity is anyway more than anything. So there is no issue.
Yeah.
So 2 will form for sure 100%. 2 will
Real.
always form real image. Coming to 3. Now 3 will have no choice. 3 itself is coming downward, right?
Yeah.
And after bending towards the normal, it will be anyway downward. Isn't it?
Yeah.
So 3 is coming already like this. It will, if it bend towards the normal, it is anyway towards the principal axis only.
Yeah.
So 3 will be definitely real. 3 will be definitely real, isn't it?
Yeah.
So 2 is definitely real. 3 is definitely real. 5 is definitely real. And 4 is definitely real. Anything after 1, or you can say anything beyond 2, everything is going to be
Real.
100% real. 100% real. The only possibility of not being real is 1.
That
So 1,
would be one possibility.
yeah,
Like,
that is only one possibility if it is less than R by mu minus 1.
yeah.
So when D is, when object is very close to the P, it will form the virtual, otherwise it is going to form real one. Now I hope this makes everything sense, like why and when.
Yeah.
So when the object is real, and it is, if the object is real, then there are two possibilities. The image may be real and virtual. But if the object is virtual, the image is bound to be real. Do you realize this? And you
Yes,
can
sir.
clearly see the fourth one will only go towards the normal. No? So fourth will bend like this only. Fourth will have no option but to go this way, right?
Yeah.
Do you realize this?
Yes, sir.
And three will have something like this. Three is coming this way. So even three will have image somewhere here. And the five will be five here, five dash for sure. And these two are real. This one is virtual, isn't it?
Yes, sir.
Just give me Okay. So the image, object, real, virtual, everything is clear. Hello, 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 guys.
Yes, sir.
Any doubt in this? Like when object is real, when image is real, and vice versa.
No.
We'll see all the cases. Don't worry. Okay. So let's take the other case, like when it is concave side, like when you see the concave side of surface, from the side light ray is coming. So if you are standing on the side in from which light ray is coming, and if you see the concave side, how it will look like? Let me do it on a separate page. Okay. So now, yeah. This is better. Now again, it is not necessary that the object must be on the air side. It is again not necessary. So let's say, because this example is very popular and very common in terms of solving questions, so we take like this. When we solve actual problem, I will give you all types of example. Like the object may be kept in the potential medium also. So again, the same procedure, like nothing new. How you're going to start with? You will write the Newton's law of refraction formula. The P is here. And this is your incident light. Okay. So the way we proceed is simple. The mu2 will be how much? What is mu2? The refractive index of second medium is?
Mu.
And what is mu1 here?
1.
Very good. That's simple. What is R here in terms of sign?
Negative.
So R will be negative. The radius of curvature will be negative in as per the formula. Okay, but here R is the radius of curvature given. So when you substitute R in the formula of R, we have to put with sign. When we are not aware about the sign, we just keep it R. And when we try to derive R, when we know R, we have to put with sign. So formula R is symbol and here R is value. So what you need to understand is the symbols are without sign. The values are with sign if you know. And if you don't know, you just keep it as symbol. So let's write the formula mu2 by v minus mu1 by u equals to second minus first upon R. I hope this is clear. Okay.
Yes.
So let's substitute the value mu by V. I don't know about the V. I will not comment. 1 by minus D. Mu2 minus 1 by minus R. I hope this is clear.
Yes.
So mu by V is minus 1 by D. And this is minus mu minus 1 by R. So this entire term is positive, right?
Yes.
And so minus before will make it negative. So what do you see? What do you see here? In this case, there is no question of a real image. Do you realize this?
Yes.
So real object will have 100% virtual. So real object will have only virtual. Can we have the real object and real image? Totally discarded because there is no scope here. Can you see that? There is no scope. So now we will have to try the virtual one. So what if the the incident ray itself is hitting at some angle above the horizontal? So if we take above the horizontal, the object is going to be like this. D is here, P is here. So tell me what we can write again. It's the same equation, but the U will change the sign. Mu2 by V, 1 by plus D, right? Is this clear? So luckily what we're getting is a different answer. So mu by V equals to 1 by D minus mu minus 1 by R. And now there is a possibility that this can be positive, isn't it? And there is also a possibility this could be negative. Yes or no?
Yeah.
Now everything is possible. It means the virtual object will give two possibilities. The RHS can be positive, which means it is real. And the RHS can be negative, which means it is still virtual. So both are acceptable. It is very much similar to mirror. The same logic is with mirror also. If you remember that concave mirror can form everything except virtual, and concave can form everything. Oh, it's mirror, it's opposite. Convex mirror can form everything except real, and concave mirror can form everything except virtual. Something similar to that, but in a reverse order. Do you realize this? Yes or no?
Yes, sir.
So there are so many layers to the ideas. Okay? You can always draw the, see, that's why it's called ray optics. You can draw the ray and get your answer. If you want to do the research, let's say the way we analyzed in the previous case, we can also do similar here. And you can feel it for yourself. So, okay. Just to change the instance, I will draw something like this. Hmm. So first of all, what I'll draw is I'll draw a center of curvature. I'll just draw C somewhere. Because once I draw C, I can draw the normal, right? You can see this is the normal, which we have drawn at this point. Now, what are the possibilities? The object on the left, object on the right, and object at C itself. And what will happen if the object is at C? Where the image will be? If the object is at center of curvature, the image will be there only, isn't it? Because this light ray will go this way only, and the light ray which will go like this will go this way only. And because they will never meet on that side, so they can be brought back. And so what you get the virtual image at C, isn't it? Is this clear? Yes or no? So now let's do multiple lines. If object is here, it will hit like this. It will hit like this. And if you take virtual object somewhere here, in case if the object is virtual, so what will happen in that case? You will hit like this. It means the light will come from this side. Understood? So I have taken all the cases. The pink one is for the virtual object, and the rest are for the real. One more you can draw if you want. You can draw one more. Okay. So now let's analyze one by one. Every light will bend towards the normal or away from normal, because light is coming from the rarer medium. So it will bend towards the normal, isn't it?
Yes.
Okay. And where is the normal? You can see this is the normal. So this will bend like this,
Yeah.
like this also.
No,
So
sir.
this is about the green line,
Yeah, the green. No, this is for the pink line.
pink line.
For pink, so for pink, what will happen? It will bend towards the normal. So it will bend like this, small value, more. It can come horizontal also. And then it can bend like this also. The only case when it will bend above the horizontal, but towards the normal, it will form the virtual image. Do you realize this? Because it will be coming from somewhere here. The image will be somewhere here, right? So for pink line, let me do the pink only. For pink line, how many possibilities are there? So these are which images you can see? Image is real, real, still real, and now it is. If the ray will go this way, the image will be. It will never meet the principal axis, isn't
Virtual.
it? So the image will be virtual. Okay, so it means the virtual object can have real image and virtual image. Yes or no?
Yeah.
And you can do this animation. You can understand, okay, this can go from here to here. So between these two, between this angular displacement, we have both possibilities of real and virtual image. I hope you can see this. That's quite logical. Is this clear?
Yeah, sir.
So this is removed. Now, if the objects are real, either blue or the red, green. So for red, for green, there is no option. Green will bend like this one, right?
Yeah.
So green is definitely virtual.
Yeah.
And for this blue, let's take a blue. For this blue, it will bend towards the normal like this. Even in the worst case, it can bend only this much, no? Tending to 0. So for this O, the image is again only virtual possible. You can see. It will never meet the, because above the normal, this ray cannot meet the principal axis, isn't it? For any angle from here. Do you realize this? Will it ever come down? Hello, hello, hello.
Sir,
This,
no.
this light ray can come down this side.
Sir, which light ray is it like?
This one,
Oh.
this one,
Oh.
this one. So if I draw, if I turn the light ray towards the normal, will it ever come below this line? The normal itself.
No, no.
It will be above the normal, no?
Yeah.
So again the only possibility is virtual image.
Yeah, virtual.
So the only thing is every real object will have only virtual image. There's no other possibilities. Understood? So real can only form virtual. Do you realize this?
Yes, sir.
Okay. And virtual will have two chances, two possibilities, real and so if the object is virtual, then what are the possibilities?
Sir, both real.
Have you realized this?
So, but here in the first case, it was forming a real image. no?
Which case? Which one? Which color? For a blue one. For blue one, the objects are real,
Yeah,
but images are
virtual.
virtual. Because it will never become horizontal also. Do you realize this?
Sir, the pink one.
The pink one will have both, no? Real and virtual. See, every light after reflection will bend towards the normal if it is denser medium, isn't it? That is the basic.
Yeah.
So this light ray can bend like this, can bend like this, can bend like this. So it will have both chances. It can meet the axis, it cannot meet the axis. Like this will not meet the axis. Isn't it?
Sir, but that ink ray is from a real object. No.
No, the pink one is the virtual object. Who said it's real? How pink can be real? The light is coming from somewhere here, no? The incident ray is coming from where? Do you see the origin? Do you see the origin of pink ray?
No.
If you don't see the origin, it means you don't see the object.
Yeah.
So it's virtual object.
It's virtual. Yeah. Okay.
That's why I have shown by the dashed line. The dashed line for the O is representing it. This is virtual object. But this is real object. This is real object.
And the green is also real at infinity.
Yeah, yeah. At infinity. So until you're not taking a pen, paper, and not drawing all this, you will never realize all this thing. Then you have to just remember hypothetically. If you want to understand organically, then draw it and feel for yourself. This is one practice that everyone should do. If someone wants to understand the ray optics in deep, if you want to solve question, it's easy. To solve question, you need to good with formula, how to use it. That's it.
Yeah, sir. I drew them, but I was continuously drawing, so that pink one also I just drew and I said that it is real. But then I realized that it's virtual.
Yeah. Clear so far, so good.
Yes.
So now we are good to go with numerical. So let's start with any question. Just a random question. Now, if we have two media separated by a spherical surface of curvature R, then the question is, if a light ray coming parallel to the principal axis, which light ray is this? Coming from infinity? Okay.
Yeah.
So after refraction, it will meet somewhere. Because anything coming from infinity will always form the real image. Yes or no?
Yeah.
We have discussed this, right? So this is called the focus. For this beam, the F is the focus. Can you find the F, or you can say PF? So let me call this as focus. Because by definition, the focus is that thing. Any parallel beam coming parallel to the principal axis, wherever it meets the distance of the pole to F is called the focus, or focus. This length is called focal length. So find the focal length. So focal length is nothing but the image distance, right? So right now I'm saying the image distance as focal length. Do you realize this? I'm saying this. Hello, hello, hello.
Yes, sir.
So tell me the answer. What you are getting? So write your answer in terms of mu1, mu2.
Sir, but this F is the
Image distance, come on,
image
it's given to
distance.
you.
Oh, yeah.
And this image distance is positive or negative?
It's positive.
Very good. Go ahead. So what you will substitute here?
So for the U, we have to take as minus infinity.
Correct, correct, correct. Very good.
So then that mu1 by infinity becomes positive and becomes 0.
Yeah, mu1
And-
by infinity is 0 only. So we can always make it 0. The second term on the LHS will be 0. Sorry, in the LHS will be 0, right? So how you thinking of
So
writing
f
this?
is equal to r mu2 minus
Mu2
mu2.
by plus f. This is infinity.
Yeah,
Mu2 minus mu1 by plus r.
yeah,
So mu2 by f is mu2 minus mu1 by r.
yeah.
So f is how much?
mu2 r by mu2 minus
Mu2 r by,
mu2 minus.
that's it. So here we don't have something like f equals to r by 2. We have f equals to in terms of mu. So if I take mu1 as air, the answer becomes mu2 as mu. The answer becomes mu r by mu minus 1. Understood?
Yeah.
That's the answer. Simple. So if I draw something like this, and we have mu1. On the right hand side, we have above the principal axis we have mu2, but below the principal axis we have mu3. Okay. And now the light ray which is coming from here, let's say after reflection, this will meet somewhere here. But the beam which is coming from below, so basically, if the light ray is coming from infinity, if it happens to hit the above the normal, above the principal axis, the image location will change. So we can have I on I2, there are two images. Basically, we have two foci, correct? And because we have two foci, then we can talk about the gap between them. So what is I2 minus I1 or whatever? I don't know which one is bigger. I want this answer. I hope this is simple. So on the LHS, we have same media, above and below. On the RHS, we have different. Is this clear, guys? Hello, hello, hello. Is this clear?
Yeah, sir.
Solve this.
Sir, I got the expression.
Yeah.
Sir, I
Okay,
was
so I
trying to
think, yeah, you
simplify it.
can just write the same way. So you can say F1 equals to something like mu2 R by mu2 minus mu, right?
Yeah, and F2 is equal to mu3R by mu.
Mu3, yeah, that's it.
Yeah, sir, I was trying to simplify, but it was too big.
No need to simplify. So we have no idea which one is bigger, so we can just take the modulus. And we cannot simplify because this is multiple mu here.
Yeah, so
We-
just take the R component.
Yeah, we can only take R. Okay, so that's a simple question that you can solve. The same question can be asked in terms of object also. So they may give you object distance, and so let's solve a simple question similar to this, just for practice. So we have an object here, and this is a. This is mu, which is 1.5, and this is mu, which is 1.3. Yeah, fair enough. Find the distance between the images of the object. Try this. The radius is now, I have to give them the value. Uh, let's take 15 centimeter.
So 20 centimeter.
I'll check. So, but u is not given. How you can solve this question? Oh, sorry. So u should be given. You have taken infinity, something like that.
Yeah.
Okay, that's right. Okay. Yeah, for infinity, if the object is at infinity, that is the right answer. But what if the object is at O, which is
Oh,
20
so
centimeters?
just 1 minute. Sir, I got 46.7.
Okay, that's fine. Just let me do some more practice problem. Just one minute.
Sir, are you there?
Yes, yes, I'm there. Just I was trying to send a question actually. Now I have sent. So instead of writing the question again and again, I thought of giving this question. Now we can solve from there directly. Okay. So open the PDF which I have shared. Can you see the PDF?
Yeah, sir, I opened.
So we'll see some unique problem, and then no need to solve all questions. Okay. So you can see question number 23. So solve question number 23, and then 24 or 25 you can solve 24. Let's solve question. I'll just tell you the question number
Sir, the question you gave right now.
right now. Yeah.
Sir, no, before this you gave no for solving.
I have given something. If I have given this, send me again, because I don't. I will lost everything.
Sir, no, right now, no.
Yeah,
Previous
right now. Yeah, right now. Only. Right now I have given 21 pages. You can see.
Yeah, sir, that's on WhatsApp. I'm saying before this on the 7th slide, you gave one problem to solve.
Ah, okay. Here. Okay. This
Yeah.
one. No? Okay. This you can solve. So for
Sir,
topmost
but I
point,
got V negative for some reason.
that's quite possible. No? If V is negative, it means it is on the left side. So that's quite possible, because see, if you compare, see, let's find the D for the top. D up. So D up you can write as R upon, just see the value, or you can find the what is R upon mu minus 1. R upon mu minus 1 is how much? 0.5. This is 30 centimeter.
Yeah.
You can just check. And R upon 0.3, which is how much? 50 centimeter.
Yeah.
Which means both are, the D required is for real image should be more than this. So for real image, D must be more than this. So do we have D more than this? No. Both values are saying 30 and 50. So, but our D is 20 only. Understood?
Yeah.
So our D is actually less than this, no? So we will get both answers negative. So both V1, V2 will be negative.
Yeah, sir, I got one as minus 90 and the other one as minus 43.3.
Yeah, that's correct. So whatever you got is right answer.
Yeah, okay. Then it
Yeah.
will be good.
You can see this. That's why this is the checkpoint given. Just by writing R upon mu minus 1, because you can see right is mu, left is air. The moment you substitute the value R upon mu minus 1, you can get to know that, okay, whether I'm going to get the real and virtual. That is like a quick test. Understood? So
Yes.
D is our D. This is D. Our D is less than this value, no? So virtual image. And that's why the answer I'm expecting is negative. Correct?
Yes, sir.
And okay, then by writing the formula, you can get the answer. So that's the right answer. So now let's solve question number 23. So 23, then 24, then we'll not solve all. We'll solve, it's all are similar. It's very simple. I mean, nothing big deal. Then 33, slightly different. 34, just for practice. That's it. Solve 4 questions and you are master of this. Then we'll solve. This is before subjective 2. This is, yeah, this was the before subjective 2. And then we can solve question number 4 afterwards. 5, which is important to solve. 4, 5. Okay. And I don't know why they have given this question, but they should not have given. We'll solve 4, 5. Oh, yes, mix actually. It's a whole chapter. Then 7. Then 8. That will be sufficient, I think. Yeah, that is sufficient. Then I will solve 37 particularly because that's my favorite question. 37. That's it. Yeah. Okay, I need to give the answer for that one also. No? The initial 23 to
So for the 23rd one, I'm getting a big expression which cannot be solved.
fourth, which one? 20.
23.
Find the image of the point object. N2 is N. N1 is 4 by 3 and this is P. So what's the big expression? It's a simple formula. N minus N by V upon like 4 by 3. I think they mentioned, okay, they might have missed the value.
Yeah. So P also and N also are there.
I think N1 is 1. I mean, let me see if I can solve. N2 maybe 2 maybe. So 4 by 3 minus P, right? And then, okay, I'll find out N1 by R is 20.
Plus R plus 20.
Yeah, plus R. Okay, that's fine. So, and they have given, and the answer given is, I think, 10 by 9. Oh, what is this?
R is given as 20.
Just a minute. Okay, it's n is given roughly 1.5. I mean, the answer given is 1.5 roughly. Okay, they're asking n only. What is okay.
No, sir, they're asking V.
They have moved up this answer. Okay, P is given as 20 only. Take P as 20. I think now you can find N. Question is wrong given. So it's like okay, I think they have given a different question and everything is disturbed. Okay. Cancel this, 23. Solve the next one. 24. Let me read it if it is having everything. Yeah, this is easy. Yeah, you can solve 24.
Yeah, sir, it's very easy.
Yeah. So you can solve 26. 26 is also easy. You can solve.
Sir, all are like formula based on.
Yeah. That's what I'm saying. See, totally we are done actually. So what we can do is we can leave this part. You can practice at home and just check for see for yourself whether you have got the answer or not. We can directly go to the next concept. This is very trivial questions and just apply the formula, get the answer. It's like waste of time. Okay. So I'll go for something else. You can go for lens now. And we can also do some, you can also do motion analysis and magnification part of it. Yeah, you can do the, let's do the motion analysis quickly. Motion analysis. It's again formula based. So we can add mu2 by v minus mu1 by u equals to mu2 minus mu1 by r. On the RHS, everything is constant, right? So if you differentiate, what we get? Minus mu2 by v square into dv by dt.
Yeah.
And minus mu1 into minus u square into du by dt equals to 0. So now what we need to realize that this is velocity of image with respect to interface. I can say point P. That's how we understand. because the u and v we measure from p, right? Because the u v are measured with respect to p, so we have to we have to write like this one, and plus, and du by dt will be velocity of object with respect to point p. Is this clear? Hopefully.
Yes.
So mu2 by v square is mu1 by u square into VOP. So velocity of image with point P is v square by u square into mu1 by. Okay. And if you remember the magnification formula, if you remember the magnification was how much? It is v by mu2 upon u by mu1, right?
Yeah, sir. V by mu upon u by.
So I can multiply by mu1 by mu2, and I can further multiply by mu2 by mu1. So this will not affect the answer, right?
No.
And now I can take these three, which becomes m square. So VIP, oh, that looks nice. VIP. So VIP equals to, it is v by mu2 whole square and u by mu1 whole square. So it looks like m square into mu2 by mu1 into VO. Yeah, so you can write like this. So that's it. You can just do it. See, in examination, you have to just use the formula. Now VIP we can write as VI minus VP. And I'll just keep it as such, the way we derived. And VOP is VU minus VP. So if you want to rearrange, you can rearrange. So VI is and there is one very famous magnification formula in terms of radius of curvature. So we know magnification is how much? V by mu2 upon u by mu1. Okay.
Yes.
And we have the formula mu2 by v minus mu1 by u is mu2 minus mu1 by r. Okay. So what we can do is we can write mu2 by v minus mu1 by u, mu2 by r minus mu1 by r, and I'll rearrange the mu2 one such mu2 into 1 by v upon 1 by r is equals to mu1 into, like this. We can write like this. Okay. And we can take a 1 by v common from this side. So, or anyway, you can write like this. As of now, you can write, I'll just write like this, mu2. Take LCM r minus v upon rv, r minus u upon re cancels. So this is a very famous way of writing. So mu2 by v is r minus u by r minus v. Okay, and this is how much into mu. This is mu2, my bad. Mu1 by u. So if we rearrange, it will look like r minus v upon r minus u. I will just shift this side. This becomes v by mu2 into mu1 by u, which itself is magnification, right? So without mu, you can write magnification in terms of r u v. So if you know the u v and all, you can find answer. So it is r minus v upon. What does it mean is that if you can find the distance of object and image from the radius of curvature, and if you take the ratio, we'll get the magnification. So this is the formula without mu and mu. If you know the UV in advance, you can use the formula to get the answer directly. So rest you can do like solving problem is like using formula again and again, and that is your duty. Okay. What else I can do here? I think we are done with the reflection from curved surface, but I'll take one question, which is, as I said, question number 37. What if we have multiple surface through which the reflection will take place? So you have to apply the formula multiple times. Okay. So I'll take few questions which are having multiple reflection. So imagine we have a spherical or simply a transparent sphere with a finite diameter, of course. So we will keep our object close to the diameter. So we'll always use the paraxial rays. If the object is here, we'll assume that our rays are hitting this portion, and the radius of curvature, you can call it r. But the observer is on this side. So the light ray will suffer how many reflection before it reaches the observer?
2.
So as many reflection, as many times you have to use the formula. Okay. So if I give this as d, this is I give as mu, then how we begin? So first reflection is here. So for first refraction, we can write mu2, which is mu, because you are entering to the medium, mu2 by v, which we don't know, but we'll call v1 because this is the intermediate image before, because we are going to suffer one more refraction. So I will say v1 minus mu1 is 1 and u is minus d. Mu2 minus mu1 by plus r. It is clear? No need to solve and rearrange, just write the equation the way it is. So mu by v1 plus 1 by d turns out to be by r. So call it equation. So for second refraction, you have no idea because v1 is either right or left. I have no idea. Nothing I can say. So what we do is we never write the v1. What we write is the formula again. So the way of writing is for second surface, the mu2 is 1. Okay. It is clear?
Yes, sir.
Okay. But the image we don't know, so we can call it v. But the first surface, the first medium is mu. But what is the image? So
Sir,
there are
what?
two ways of thinking. Yeah, tell me.
So what did you ask?
How to substitute the u for the second surface. So let's say if I choose V1 as positive, what does it mean? Okay, let me write down one more time. We have to write the reflection again, na? So what is mu by V1? Let's say this is mu minus 1. And I can assume this term as positive. I don't know the sign of this, but let's call it positive. So 1 by V1 is how much? Or simply mu by V1 is? If I assume this to be positive, let us assume positive. Then image will be on the right hand side.
Yeah, on the
So
right
this will
hand.
be, so the V1 is assumed something like this.
Yeah,
Now the image of the first surface will act as the object for the second surface.
yeah,
And that will be how much? 2r minus V1 on the left,
yeah.
isn't it? So for second surface,
Answer, it will be negative.
yeah, it will negative. So we are writing value there. When we substitute, we'll put with minus sign. So for second surface, what we can write? Mu2 by V, which is the final answer, minus mu1 by U, which is how much? 2r minus V1 with minus sign, right? Equals to mu2 minus mu1 by R, which is minus R. Is this clear?
Yes, sir.
And R is a value. R is not a. I mean, so V1 I have taken as positive, but when we substitute, it's so basically mu by V1 we can add here as by okay. So V1 is mu D. So generally they will give you values, so it's easy to solve. I'm not taking any value as of now. So this becomes tedious to solve 1 by V plus mu by 2r minus mu r d upon d mu minus 1 minus r. I can write this as mu minus 1 by plus r. And now this you can solve. I mean, given a value, this could have been solved easily, right? So the whole idea was that how to solve when we have multiple refractions. So object, the image of the first will behave as the object of the second surface, but you need to figure out the actual distance in terms of the way you assume the V1. I have taken V1 as positive. Okay. And so it was easy for me to write. So based on that, you can solve the question number 37. 37, I hope you can see.
Yes, sir.
Just solve that one. That will be sufficient.
Sir, 37 of the second, like third page only.
Just
Well,
the first one, the 23 page question. Yeah, it is the last page. If you have to come really below, then 37. Yeah. Come to the 14th page on the PDF. You can see the 37 now.
the quarter circle one.
Yeah, exactly. The quarter cylinder.
Yeah, the quarter.
Yeah. So if the surface is flat, you can still apply the same formula, because for flat surface the R becomes for flat surface, and this is the your actual apparent and real depth formula. So V by mu1 is V by mu2 is U by mu.
Sir, I got 4/3.
That is the right answer. Very good. So that's the right answer. 4/3. So if it means now you have understood the multiple
Yeah.
surface reflection, it's not difficult. Just like you have to do it repeatedly. So we'll do one more problem. So we have a lens. Oh, but that is like lens. No, that's not. So one surface is flat, other is having curvature. So just now in this question, this is the 4 centimeter gap, and the radius of curvature is 4 centimeters. The R I can take is 10 centimeters. That's better. So the radius is 10 centimeters for curvature per part, but the depth is 4, and there is an object kept at the bottom, and we have to look from this side, of course. Find the image distance in each case. The refractive index is 1.5 in each case. Are you solving this question? Hello,
So,
guys.
so the
Are you
whole, like,
the whole is not. This is not whole. This is the distance given actually. That's why I was
no,
showing
sir,
using a line.
the whole, the
I don't consider as a whole. Okay. The gap is 4. Okay. If it is confusing, I will.
so, but the object is,
Object is at the bottom. Object is at the bottom, as you can see.
yeah.
I hope you have written the question. I'll just the next page. So while you're solving, I'm going to write some question. Two interesting problem that you should solve. Okay, so these are two questions, and if you solve these two, it means the concepts are really clear.
So can you solve the one before this?
Pardon?
Can you solve the one on the previous slide?
Yeah. So first of all, if the object is at O, okay, the O is the bottom, light ray will enter. So if the light ray will enter, it will suffer reflection at that point itself, isn't it?
Yeah.
But it is touching that. So because it is touching the surface, so it will enter from surface itself. So in this case, if O is slightly outside, there is a refraction suffering. I mean, here the U is how much from the curved surface? U is 0.
Yeah. So
If U is 0, V will be how much? What will be the V value if U is 0? You can solve.
so if we use that formula, then u is in the denominator. Anything divided by 0.
Is infinity. So here what we are assuming is actually the question is not that. The question is like there is a black spot painted on the surface. So the light ray we have to assume begins from O and it will suffer the reflection only on the second surface, not on the first surface. That is what we're going to assume. The reflection taking place on the second surface, not on the first surface. So for second surface, what is the reflection? It's a reflection from plane surface. And
Yeah.
because it is reflecting from plane surface, we can directly use the formula. Which formula? Apparent depth and real depth. So in the first case, the V by mu2 is U by mu1. And we want to find V mu2 is air. Sorry, mu2 is yeah, air. And U is 4 below. And what is mu1? It is 1.5. So that's the direct answer. So V is how much? 4 by 3 by 2, 8 by 3. That's it. So the image form will be at a depth of 8 by 3 centimeter from here. This is the image point. Why? Because the refraction is taking place from the flat surface. We could have used directly the formula. Or even if you try to use the formula, or how to write mu2 by V minus mu1. Mu1 is 1.5 by U, which is minus 4, is equals to mu2 minus mu1 by infinity. And this becomes 0. So you will get the answer as 1 by V equals to minus 1.5 by 4. So V turns out to be minus 8 by 3, and minus means it will be on the same side as the object. So it is below the interface. It is clear? Understood? For second case, what is happening? The reflection will take place from the curved surface, right? So what you write? You write formula mu2 by V minus mu1 by U is mu2 minus mu1 by minus sorry, by R is minus 10. Why minus 10? Because the R is on the below side and the ray will go up. Do you realize this part?
Yes.
So the answer will change. No? Minus. This will become plus 0.5 by 10. So you can take LCM as 20. So 4,520 minus 7.5 minus 6.5. So minus 40 by 13 centimeters. The answer will be below, but the answer is roughly 3 point something, roughly 3 centimeter below. So earlier it was 2.66, now it is 3 centimeter below. So the answer is different, right? I hope this is clear. So in this case, the light ray will travel like this. And so the surface will get a refracted curve. In this case, the light ray will travel like this. And the surface you will get a refracted plane surface. So that is the only thing which you have to take care of. Is this clear?
Yeah.
Yes.
And when you put a u equals to 0, it is giving infinity. So first you rearrange, then put the value. Don't put that time. All right. So now we can come to this question. So this radius is given. If you okay, first you read the question. I think you haven't read it. Have you read this question? So RS is the radius of a sphere, RB is the radius of the beam, a parallel beam is coming. So beam will first converge because parallel beam will try to form the real image. But because it will try to converge, it may hit the second surface before it actually converges. So it is quite possible that it may converge like this, and before it will actually converge, the medium will abruptly end. So it will suffer one more refraction. Like this, and then the light ray may go like this. So the spot may change, right? The size will change. This is the new spot. So that is the question, like what is the big spot value? So if you use the refraction, then to get the final image, you have to use the similar triangle or something like that. So try this out. If you can think something.
So,
And here you are supposed to use the Snell's law, not the formula. Why? Because R is given. What does it mean? We are not saying that it must be, but this could be per excel because R is very small compared to the RS. Yeah, this could be per excel. It is 0.5, it is 20. But anyway, I will prefer you write through the
last
basic.
page in case one.
Pardon?
In last page in case one, we can assume the length as a slab, right? So
In the last case, you are saying to a previous problem.
in case one,
In
we
case
can
one,
assume
yes.
it like a slab. Use the D
Yeah,
here
yeah,
and
yeah,
the
yeah, yeah.
apparent
Correct,
formula.
correct. Exactly. That is what I was saying, that you can use thing, you can think as slab, and then you can solve the way you have done before. The apparent and the real will be sufficient. Okay. So now solve this. or I can give this as a homework. You can try this at home. Okay. And spend some time. Like we may spend 1 hour or maybe half hour. I'll tell the answer. Just a minute. No need to worry. You can have the answer. You can check the answer. Then you can solve. So,
Sir, you were explaining something, no, how to approach this.
yeah, you have to use the Snail's law actually. The real Snail's law. Like you have to draw the diagram to get the actual angle of incidence, because RB is given. So you can, when dimension is given, then it is not paraxial. And therefore you have to use the Snail's law in reality. I mean, you cannot use the formula. That is the condition of this problem. Understood? Because if you draw a circle, I'll just give you hint. And if something is hitting like this, you can draw normal like this. Okay. So this height is given to you, no? RB, and this is RS. So you got the angle of incidence, right? And then you will apply the Snell's law to get the new angle. And then probably you can find the final angle. Because the angle is required, then only you can find the radius. Until we don't know this angle, we cannot use this angle, right? And so until we know theta, I cannot find this R. Understood? So
Yes.
that's why this is the question. You have to solve without using the formula. You have to use the actual Snell's law application. So the answer is roughly the answer given is L minus RS RB by RS. You can use approximation because RB is very, very small compared to RS. This is the answer given. And for this question, or you can prove it, that's itself is a question. And then for this question, this is question number. The R is so these are very challenging problem. If you can solve, it's really good. I don't expect that you must be getting the answer, but if you try, you will learn a lot of things, and then I will solve. Okay. So this will be your homework, and try this out. Next lecture, I will start the thin lenses. So probably thin lens will be the last topic. We should be able to finish this. Then we have optical instrument. I will try to teach that also if time is permitting me. Hopefully I will teach, but I will not practice much. I'll just give you all the theory, and you can start solving from AC1, those chapters. All right.